Hello and welcome to episode 2 of the ComfyUI tutorial series. If nodes and workflows still look confusing, don't worry. By the end of this video, they'll make complete sense. In this episode, we'll begin by understanding what ComfyUI Manager is and we'll install it step by step. After that, we'll clearly go through the basics of nodes and workflows so you can understand how ComfyUI works and feel confident using and modifying workflows. If you haven't downloaded or installed ComfyUI yet, I recommend watching episode 1 first, where we covered the basics and completed the manual installation. Once that's done, you'll be ready to follow along comfortably in this episode. First, let's quickly understand what ComfyUI Manager is and what it does. ComfyUI Manager is a powerful extension designed to enhance the usability of ComfyUI. It offers management functions to install, remove, disable, and enable various custom nodes of ComfyUI. The tool is super user-friendly and allows both beginners and advanced users to manage their ComfyUI setup without the need of extensive technical knowledge, making it a popular choice to manage nodes and workflows. Installing ComfyUI Manager is quite simple. To begin, we'll open the official ComfyUI website. I'll leave the link in the description below. On this page, you'll see different installation options. But since we installed the portable version of ComfyUI in our last episode, we will focus on the portable user section. According to the official documentation, ComfyUI Manager is already included in the core setup. So in this case, we don't need to install anything extra. We only need to enable ComfyUI Manager so that we can start using it inside ComfyUI. As you can see, to use ComfyUI Manager, we first need to install its required dependencies and then enable the manager inside ComfyUI. To install the dependencies, we'll start by navigating to the ComfyUI portable folder. Once you're inside this folder, click on the address bar and type cmd and press enter. This will open a command prompt directly in this directory. Alternatively, you can right-click inside the folder and select Open in Terminal to open a command window. Now, let's go back to the official ComfyUI website and copy the command provided to install the manager dependencies. Once copied, return to the command prompt, paste the command and press enter. This step will install all the required dependencies needed by ComfyUI Manager. Wait for the process to finish completely. After the installation is done, go back to the ComfyUI portable folder. Since I am using an NVIDIA GPU, I will right-click on the Run NVIDIA GPU.bat file and open it in any text editor. I will now go back to the official ComfyUI website and copy the updated launch code provided in step 2 and replace the existing code in the batch file with the updated code and then click Save. Once this is done, we simply need to launch ComfyUI again by double-clicking the startup file. Once the interface is open, you'll notice a new icon at the top of the screen. Click on this icon to open the Nodes Manager. Inside the manager, you will see a list of custom node packs that can be used in your workflows. You can scroll through this list and choose a pack based on your needs. When you click on a node pack, you'll see more details on the right side. Under the description tab, you will find a detailed explanation of the pack and a link to its GitHub repository. If you click on the Nodes tab, you will see a list of individual nodes included in that pack. This is useful if you want to know exactly which nodes will be installed. To install a node pack, simply click the Install button. You can also select multiple packs and install them together with a single click. After installation, you'll see a message asking you to apply changes. Click Apply Changes and ComfyUI will restart automatically. Once ComfyUI reloads, you'll see a confirmation message showing that the extensions have been installed successfully and are ready to use in your workflows. To uninstall an extension, select the node pack and click Uninstall. Then click Apply Changes again to reload the ComfyUI interface. Sometimes, we need specific functionality inside a workflow, such as comparing two images. For tasks like this, we need to use custom nodes. The ComfyUI Manager allows us to search for a node pack using the node name itself. To do this, open the manager. From the drop-down menu, select the Nodes option. Now, type the name of the node you want to use into the search bar. This will display all the node packs that contain the search node. Select one of the node packs from the list. To cross-check, click on the Nodes tab on the right side. As you can see here, the Image Compare node is part of the selected RG3 nodes pack. To install it, simply click the Install button. Wait for the installation to complete. When prompted, click Apply Changes to reload ComfyUI. ComfyUI has restarted successfully. Now, double-click on the workspace. Type Image Compare and check if the node is available. As you can see, the Image Compare node is now available and we can select it to use it inside our workflow. This is how we can enhance the functionality of workflows by using custom nodes. Now let's see how ComfyUI Manager helps install missing custom nodes in a workflow. I've downloaded a workflow from comfyworkflows.com. To load this workflow, simply drag and drop the file onto the ComfyUI workspace. When you load a workflow that uses nodes which are not installed on your system, ComfyUI will notify you. In most cases, you'll see a dialog box listing the missing nodes, along with an option to install them automatically. You may also notice that the missing nodes in the workflow are highlighted in red. From the dialog box, you can click Install All to download and install all missing nodes at once. Alternatively, you can open ComfyUI Manager manually. Inside the manager, go to the Missing section. Here, you'll see a list of all nodes required by the workflow that are not currently installed. From here, you can install the missing nodes with a single click. Once the installation is complete, click Apply Changes to reload or restart ComfyUI. After ComfyUI loads again, you'll notice that none of the nodes are highlighted in red anymore. This means all required nodes are now installed and the workflow is ready to use. At this point, you should have a clear idea of what ComfyUI Manager does and how it helps manage workflows. Now, before we explain nodes and workflows, let's quickly understand the ComfyUI interface itself. Let's start at the top left. Right now, since nothing is running, the state shows idle. Below that, you'll see the name of the workflow currently loaded in the workspace, along with a menu icon. From this menu, you can create, open, save, or clear workflows and manage memory-related options like unloading models. On the left side, you'll find the main toolbar. The Assets section shows images and outputs generated during your session. You can click on the Nodes section to view all the nodes currently available on your system. The Models section shows all locally available models inside ComfyUI. Right now, we only have one model installed, which we downloaded in the first episode and added to the checkpoints folder. This saves time because you don't need to open folders or remember file names just to check which models are available. When you save a workflow, it is stored inside ComfyUI's Workflows folder. The Workflows section shows all saved workflows that you can load directly into your workspace. The Templates section provides ready-made workflows that you can use as a starting point. If you're new to ComfyUI, this is a great way to start using pre-built workflows without beginning from a blank canvas. The console is very useful for viewing logs and errors if something goes wrong. I usually check this first when a workflow doesn't run as expected because it often shows what is missing or failing. On the top right, you see the Run button. Clicking Run starts the workflow execution. The number next to it shows how many times the workflow will run. If the number is 1, the workflow runs once. If you increase this number, ComfyUI will generate multiple outputs automatically. The X button can be used to cancel the current run, allowing you to make changes and rerun the workflow immediately. At the bottom right, you'll find the canvas controls. You can select a node using the select tool and move it around. You can resize a node by dragging its corners. If you hold the control key, you can select multiple nodes one by one and move them together. You can also hold Ctrl, left click and drag to select multiple nodes at once. Zoom controls allow you to zoom in or out, and you can also use your mouse wheel to zoom smoothly. The Hide Links button allows you to hide the connections between nodes, which makes it easier to view and understand large or complex workflows. Now let's look at a few useful shortcuts that can make working in ComfyUI easier. If you want to add a node to a workflow, you can double-click on the canvas. This opens a search box where you can type the name of the node and add it directly to your workflow. You can also right-click on any node to change its color. This is useful for visual organization. For example, in this workflow, we can set the positive conditioning node to green and the negative conditioning node to red to identify them more easily. You can also double-click the node name to rename it. This helps when workflows become larger and you want clearer labels. In some situations, you may want to bypass a node or a group of nodes. To do this, select the node and press Ctrl+B. When a node is bypassed and you run the workflow, ComfyUI skips processing that node. This works as long as the nodes that come after it do not depend on the output of the bypassed node. Let me show you this with an example. First, let's add a preview image node to this workflow and connect it to the KSampler output. Now, if we run the workflow, you'll see that all nodes are processed normally. Next, let's bypass the preview image node by selecting it and pressing Ctrl+B. When we run the workflow again, you'll notice that the preview image node is not processed this time and the workflow finishes without any errors. Now, let's try bypassing the load checkpoint node and run the workflow again. As you can see, an error appears immediately. This happens because the nodes that follow depend on the output from the load checkpoint node. That covers the basic interface walkthrough. Now that we're familiar with the interface, let's move on to understanding nodes and workflows in detail. What you're seeing here is the default ComfyUI workflow. ComfyUI supports many custom nodes, and it's not possible to cover everything in a single video. As we move forward in this series, we'll explore additional nodes and more advanced workflows. For now, since we are working with the default workflow, I'll explain each node in detail. This will give you a strong foundation and help you understand how nodes work together inside a workflow. The load checkpoint node is the brain of the workflow. It is used to load the AI model that we want to use for image generation. Here, I'll select the perfect deliberate model that I downloaded in the last episode. If you look closely, you'll notice that unlike other nodes, this node has no input parameters. This means it acts as the starting point of the workflow and does not depend on any other node. The load checkpoint node outputs three essential components: the model, the clip, and the VAE. The model is the core component responsible for generating images. Every image generation starts with pure noise, and the model's job is to gradually turn that noise into a meaningful image using guidance derived from our text prompts. The next component is clip. AI models can't understand text directly, so clip reads our prompt, understands concepts like objects, style, and relationships, and converts that information into a format the model can work with. The third and final component is the VAE. But before we understand what a VAE does, we need to understand how an image is actually generated, because the process doesn't start with pixels. Each image generation starts with pure noise. This noise exists in a hidden space called the latent space, which is where most of the image generation actually happens. The noise is slowly removed step by step, using the model along with guidance from our text prompts until it starts forming a meaningful image. Even at this stage, the image still exists only in the latent space and cannot be seen by us yet. This is where the VAE comes into the picture. The VAE acts like a translator between two worlds, the hidden internal world where the AI actually works and the visible pixel world that you and I can see. During image generation, Stable Diffusion does not create images directly in pixels. Instead, it works in a compressed and efficient format called latent space, which makes the whole process faster and less resource intensive. The VAE is responsible for converting data from pixels to latent space and from latent space back into pixels, allowing us to finally see the generated image. Next is the clip text encode node. Notice that this node takes the clip model as an input and produces a conditioning as an output. This conditioning is then passed as an input for the KSampler node for further processing. This node is used to process our text prompts. When generating an image, we need to tell the model what we want to see and what we want to avoid. We do this by simply writing instructions in natural language inside this node. The clip text encode node uses the clip component from the load checkpoint node to convert our natural language prompts into numerical information that the model can understand and interpret. That processed information is then passed to the KSampler. You'll notice that the workflow uses two clip text encode nodes. One node is used for the positive prompt, where we describe what we want to see in the image, and this is passed to the KSampler as the positive input. The other node is used for the negative prompt, where we describe what we don't want to see in the image, and this is passed to the KSampler as the negative input. Together, these prompts guide the model toward the desired result while avoiding unwanted elements. Moving on, the next node is the empty latent image node. This node is used to define the width and height of the latent space, which you can think of as setting the size of the canvas before you start painting. We can change this size based on our preference or model requirements. Since I'm using the perfect deliberate model, I'll set it to 1024 by 1024, which is one of the recommended sizes for this model. Notice that this node also doesn't take any inputs, and its output is passed directly into the KSampler node. By now, you might be wondering why almost everything connects to the KSampler node. It's because the KSampler is where all the actual image generation happens. It takes the latent image to define the canvas size, the positive and negative prompts to guide what we want to see and what we want to avoid, and the model to decide which AI brain is used for generation, along with several important settings. Let me show you practically how these settings impact overall image generation. The first setting is the seed. A seed is an integer value used to create a different random noise pattern inside latent space. That initial noise becomes the starting state of the entire diffusion process. A different seed means a different initial noise pattern, which leads to a different image after denoising. Let me modify this workflow so we can see this clearly. In ComfyUI, we can have multiple KSampler nodes in a single workflow to generate multiple images at once. I can select the KSampler node, press Ctrl+C to copy, and Ctrl+V to paste to create a duplicate node. I can now manually reconnect the required inputs and outputs. However, there is a faster way. Since I want to view two different outputs within this workflow, I'll press Ctrl, left click and select these three nodes together. Now I'll press Ctrl+Shift+V. This duplicates all three nodes with their internal connections preserved. I don't want to save these images to my system, so I'll hold Ctrl, select both the save image nodes and press delete to remove them. Next, I'll double-click on the canvas, search for the preview image node and add it to the workspace. To duplicate the node, hold Alt, select the node and drag it, and make the necessary connections. Now, I'll set the seed in the first KSampler to 1, and in the second KSampler, I'll set the seed to 2. I'll click the Run to execute the workflow. Notice that we are using the same prompt, same model, and same settings in both samplers. The only difference is the seed value, which defines the initial noise pattern. That is why we get two different images, even though everything else is identical. Let me show you something interesting. Let's set the seed in both the samplers to 1 and run the workflow again. Since there is no change in the seed or any other parameter, the output is also identical. This means that if we use the same seed, same settings, and same prompt, we can reproduce the same result. You might have noticed that after each run, I had to reset the seed value manually. This happened because the control after generate option was set to randomize, which assigns a new random seed every time the workflow runs. If we want the seed to stay the same between runs, we can set this option to fixed. There are also situations where we want the seed to change, but not randomly. In those cases, we can use the increment or decrement options. Now let me show you how the number of steps impacts the output. Steps define how many times the KSampler processes and denoises the latent image. To demonstrate this clearly, I'll add an image compare node to the workflow. I'll increase the steps in the disk KSampler to 50 and decrease the steps in other sampler to just 3. I will keep everything else identical. Now, let's run the workflow and wait for processing to finish. As you can see, the output from the KSampler with lower steps contains a lot of noise. This is because the KSampler only took 3 passes to denoise the image. However, the second image is much clearer because KSampler took 50 passes to denoise the image. If I open the console window, you can see that the higher number of steps took longer time to process. We could increase the steps even further, but after a certain point, you start to see diminishing results or even worse outputs. That's why it's best to start with the step count suggested in the model documentation. Next, let's look at CFG. CFG controls how strongly the model follows the prompt. Let me isolate just the CFG setting while keeping everything else the same. In the first KSampler, I'll set the CFG value to 1. In the second KSampler, I'll increase it to 20 and then click Run. As you can see, using extreme CFG values has resulted in poor outputs. The output from the KSampler with 20 CFG looks unnatural and overexposed, while the output from KSampler with CFG set to 1 failed to follow the prompt. Now let's change the CFG value in one of the samplers to 5, which falls within the recommended range for the perfect deliberate model, and run the workflow again. As you can see now, the output with a CFG value of 5 looks well balanced. This shows that extreme CFG values can hurt image quality. It's best to start with the model's suggested CFG range and experiment with different values to find the ones that fits your use case. There are also many samplers and schedulers available, and each combination can produce slightly different results. Let me change the sampler and scheduler in one of the KSampler nodes. Let's hit run and wait for the process to finish. I will zoom into the compare image node to see the difference in the outputs closely. As you can see, there is a subtle difference in the generated image. You can experiment with different combinations to find what works best for your style, or safely follow the model recommended combination as a starting point. Finally, let's talk about denoise. Denoise controls how much the image is generated from noise. A value of 1.0 means the image is generated entirely from scratch. Lower values are mainly used for image-to-image workflows, which we'll cover later. At this stage, the key takeaway is that the KSampler is responsible for actually creating the image. However, its output is still not a visible image. It exists in latent form. To convert it into a visible image with real colors and pixels, we use the VAE decode node, which takes the latent output from the KSampler and the VAE from the load checkpoint node. The image can be previewed using the preview image node. To save the image, we can double-click on the canvas and search for the save image node. Then we connect the output of the VAE decode node directly to the save image node. When we run the workflow, the image will be saved automatically to the output folder inside the ComfyUI directory. That's all for today. Please leave a like or drop a comment if this helped you understand ComfyUI. In the next episode, we'll move beyond text to image. We will start exploring image to image and prompting in ComfyUI. Thanks for watching. I'll see you in the next episode.